Hello everyone, my name is Darwin Paz, my edX username is dpaz, and my GitHub username is dwn10. I am recording this video today, May 17, 2025. I chose to focus my final project on the SQL injection vulnerability. This choice is directly based on the topics we have covered in the course, specifically in the area of web application security. SQL injection is a fundamental type of attack that we learned to identify and prevent, especially in the module that dealt with database security and secure development practices. Vulnerability Presentation. The title of this project is Analyzing and Mitigating a Real-World SQL Injection Vulnerability in Web Development. The main objective is to apply the knowledge acquired in the course to analyze a real-world case of SQL injection that occurred in web development and, based on this analysis, propose effective mitigation strategies to prevent similar incidents in the future. For this project, I have researched and selected a real-world case of an SQL injection vulnerability that affected the e-commerce platform, Megadeals. Megadeals was a popular platform that offered a wide range of products to its users. The specific vulnerability I will analyze occurred in the context of its product search system. This system allowed users to enter keywords to find items and also offered the functionality to filter search results by different criteria, including price. The vulnerable function was specifically located in how the application handled price parameters in the URL. When a user applied a price filter, for example, showing products between 20 and 50 euros, these values were passed through the URL as parameters. The problem was that the application did not adequately validate or sanitize these parameters before incorporating them into the SQL query that was executed in the database to obtain the filtered results. This vulnerability was discovered through a report published by an independent security researcher. This researcher, while performing security tests on the platform, identified the lack of sanitization in the URL parameters used for price filters. By manipulating these parameters and injecting malicious SQL code, they demonstrated that it was possible to access sensitive information from the database that should not be accessible to unauthorized users. The report detailed the specific steps to exploit the vulnerability and the potential consequences for Megadeals and its users, which generated a significant alert within the security community. Fault Analysis. Now, let's delve into the analysis of this fault. SQL injection is an attack technique that exploits vulnerabilities in how a web application interacts with its database. Basically, an attacker can insert malicious SQL code into the application's inputs, such as forms or parameters in the URL. If the application doesn't properly sanitize or escape these inputs, the injected SQL code can be executed by the database. How does this work? When an application needs to access the database, it constructs SQL queries based on the information provided by the user. If an attacker can manipulate this information to include additional SQL commands, they can achieve unauthorized actions, such as reading sensitive information, modifying data, or even deleting entire tables. For example, in the case I investigated, an attacker was able to manipulate the product search parameter to inject an SQL query that allowed them to list all the users in the database, including their usernames and password hashes. The technologies typically involved in SQL injection attacks include server-side programming languages like PHP, Python, or Java, which are used to build the web application's logic. Database management systems such as MySQL, PostgreSQL, or SQL Server are also involved, as they are responsible for storing and managing the information. The vulnerability arises when the communication between the application and the database, through SQL queries, is not performed securely. In the specific case I am analyzing, the application was developed in PHP and used MySQL as its database management system. The vulnerability resided in the lack of sanitization of the parameters received through the URL on the search page. The impact of a successful SQL injection exploitation in the case I have selected was, in this particular incident, the exploitation of the SQL injection vulnerability resulted in the theft of personal information of thousands of users, including their email addresses, phone numbers, and even partially encrypted credit card information. Furthermore, the attackers gained administrative access to the system, which allowed them to modify the content of the website. This underscores the severity of this type of vulnerability and the importance of preventing it. Recommendations and prevention. To prevent vulnerabilities such as SQL injection from occurring, it is crucial to implement a series of preventative measures in web development. Based on what we have learned in the course and the analysis of this real-world case, I propose the following recommendations. Firstly, the most effective technique to prevent SQL injection is the use of parameterized queries, also known as prepared statements. Instead of directly concatenating user inputs into the SQL query string, placeholders are used which are then securely replaced by the provided values. This ensures that the database treats user inputs as data, not as executable SQL code. Secondly, it is fundamental to perform thorough validation and sanitization of all user inputs. This involves verifying that the entered data complies with the expected formats and removing or escaping any characters that could be used to inject malicious code. Another important principle is the principle of least privilege. The database accounts used by the application should have only the necessary permissions to perform their functions and nothing more. This limits the potential damage in the event that an SQL injection attack is successful. The use of ORMs, or Object Relational Mappers, can also help mitigate the risk of SQL injection. ORMs abstract the direct interaction with the database, generating SQL queries securely under certain circumstances. Finally, it is essential to carry out security audits and penetration testing on a regular basis. These tests can help identify potential vulnerabilities, including SQL injection, before they can be exploited by attackers. Conclusion. In summary, the detailed analysis of this real-world SQL injection case highlights the insidious nature and persistent threat that this vulnerability represents in the current web development landscape. We have explored how an attacker can manipulate the interactions between an application and its database, injecting malicious SQL code with consequences that can be devastating, ranging from the exfiltration of sensitive information to the complete corruption or deletion of data. By deeply understanding the operational mechanism of SQL injection and the intricate technologies involved, spanning from server-side programming languages to database management systems, we can more clearly appreciate the criticality of implementing robust and well-founded preventative measures. Parameterized queries, presented as the most solid defense, not only prevent the direct injection of code but also improve the efficiency and maintainability of the code. Thorough validation and sanitization of user inputs act as a first line of defense, ensuring that only expected and safe data is processed by the application. The principle of least privilege in database account management significantly limits the scope of an attacker's actions in the event of a successful exploit, minimizing potential damage. Likewise, the strategic use of ORMs can offer an additional layer of security by abstracting direct queries and reducing exposure to injection vulnerabilities. Finally, the regular implementation of security audits and penetration testing stands as an essential practice to proactively identify potential weaknesses in our applications, including SQL injection, before they can be discovered and exploited by malicious actors. Ultimately, as future web developers, it is fundamental that we internalize the importance of security at every stage of the software development lifecycle. SQL injection is not just a theoretical concept learned in this course. It is a real and tangible threat that requires constant attention and the diligent application of security best practices. By continuously integrating these lessons into our workflow, we can contribute to building a more secure and resilient digital ecosystem for all users.